Okay, so now we're at the last two sections. I'm going to combine these last two sections because they're not long. So technically this will be the last video for this chapter. Again, what we have learned so far, we've learned about debugging and the type of bugs that we can run into or errors we can run into. And we talked about the syntax error, then the runtime error with the reference errors. And we gave you a little table of different errors that you can encounter. It's so important that you go through that table and get familiar with those different errors. Now, does that mean you need to memorize it? No, but get a good understanding and just take note. If you could take mental notes of those error messages and what those titles of those error messages are, you can get a better understanding where your problem or your issue is. Now, again, get in a habit. I got to reinforce this. Get in a habit of bookmarking a lot of these lessons, these videos, the resources that we give you. Bookmark them. And also at the same time, if you have limited resources as far as your computer, make sure at the end of the evening when you're getting ready to go to sleep, go ahead and bookmark everything and shut it down. Let your computer rest because you are using it a lot and you want to make sure it's running at its optimal performance. Now, if you're new to this channel and you're just finding this particular video, again, the curriculum is free. You can click the link in the description, share the videos with friends and family. Anyone that's thinking about learning about programming for whatever reason, share the video with them because this is a great resource. It's free and we're here as a community to help each other. So without further ado, let's get into the curriculum. Here we go. So how to avoid debugging. While debugging is an unavoidable part of programming, you can reduce the number of bugs you encounter by working carefully. Here's some example or some advice. Start small. This is probably the best piece of advice for programmers at every level. It can be tempting to sit down and write an entire program all at once. However, this leaves a large number of possibilities when the program does not work. The errors could be hiding anywhere in the code. The more code, the more possibilities exist. Where to start? How to figure out what went wrong? When you start working on a large program, break the process down into smaller steps. Begin coding one very small part, even if that's just 2 lines of code. Then make sure the program runs properly before adding the next small part. Regularly run your code is quick and easy, and doing so gives you immediate feedback about the code will run. Keep it working. Once you have a small part of your program working, the next step is to figure out something small to add to it. If you keep adding small pieces to the program, one at a time, it is much easier to figure out what went wrong. Any errors that occur was almost certainly introduced by the last line or 2 of code that was added. Less new code makes it easier to locate the problem. What are we saying here? This is, like I said, some great advice, even though it's a small section, but it's very important, is when you started writing code, keep it simple, keep it small. And as you go further, you start adding more stuff to it, which we may call it refactoring. We may refactor our code to make it more efficient, but in the beginning, you just want to get it to work. Once you get it working, you know that at that point it worked. So when you go forward, if it breaks, you know it's the new code that you wrote that broke it. So, or you know at what point you started adding the new code. So do it in small pieces. We call them small chunks. Get little pieces working and then add to it. Okay. So Here is your new mantra. Get something working and keep it working. Repeat this throughout your career as a programmer. It's a great way to avoid frustrations and reduce stress while creating amazing and working code. Get something working and keep it working. That's your new mantra we're adding to it, right? Research has shown that with every little success, your brain releases a tiny bit of chemical that makes you happy. So you can keep yourself happy and make programming more enjoyable by creating lots of small victories for yourself. All right, so let's go to the last piece of this chapter. Asking good questions. We want to ask good questions, and the best way to do that, this is right here where I want to add to that confidence level, helping to start overcoming the imposter syndrome, because all the imposter syndrome is a lack of confidence. Well, when you start building your confidence, you start learning how to ask questions. You're looking to get an understanding. So it's a good thing to ask questions, because asking questions is going to just help build your confidence. Okay? So here, if you still cannot find the bug in your code after using the strategies outlined in this chapter, do not hesitate to reach out to other programmers. Whether you are asking your teaching assistant, another student, or a stranger in an online forum, you should first be able to answer 3 questions outlined below. Not only will these questions help others assist you more directly, but they may just lead you to the answer yourself. So we want you to really work on trying to solve the problem. But again, don't get stuck. That's one of the biggest mistakes you can do and really build more frustration, is when you get stuck on something and you don't reach out for help early on. I get it. We want to make sure we help you start thinking through the process. But at the same time, when you got to ask yourself these questions that we're going to give you to do some digging in yourself to get some understanding. But sometimes you have to reach out and get some help. And because you let it go too long, you're going to get frustrated, and then you're going to be discouraged. So learn how to ask questions to yourself first. And then when you don't get the results you're looking for, then you reach out after you've done some research. But again, don't get stuck for days on something that maybe if you would have asked some help early on in the first day after you've done your research, to kind of get someone to point you in the right direction. That's what it's all about. What is the problem is the first question. What is the problem with your code? Describe the error you are experiencing with as much detail as possible. These are bad suggestions. My program is broken. Of course, that's obvious. I'm getting the error. That's obvious. But the good question is, there is a reference error, because you know what a reference error is on line 23, but it's not clear to me what is causing it. That's something that you can ask someone to help you understand. But just tell someone my code is broken, that's not obvious. You're making a person do more work trying to help you, because now they got to stop and go through your code with you to figure out what the problem is. So they can't really get straight to the point. They got to first understand what you did, and that's your job. What have you done to try to address the problem? Another programmer can glean a lot of information by hearing what you have already tried. So you have to try something. These are bad. Asking for help immediately. We're not asking you to ask for help immediately. We do want you to try to figure it out and try different things first. And then using trial and error without a specific direction, just doing things, just clicking on buttons and just taking stuff out, that's not helping you. This is why I'm asking you to understand what's going on. Go back to the rule. Go back to the principle. Is it following the rules? Is it following the principle? And now, it's the good thing is, I added user input validation, but I'm still seeing the problem. You did some, you found some solutions that told you what the solution could be. You tried it, it didn't work. That's letting the person know that you are trying to figure it out, instead of just throwing up your hands and, hey, I don't know what's going on, I want you to figure it out for me. You're never going to progress in this if you have that type of mentality. Last one, where have you looked for an answer? Bad. I haven't looked online at all. Google JS range error and didn't see anything. I Googled JS range error, didn't see anything. Bad. I Googled JS range error Boolean expression. Remember, what is a Boolean expression? You're very detailed here. And focus and found a question on Stack Overflow that seemed relevant. I tried the recommended solution, but it didn't fix my problem. That right there is some good information to give to someone to help you. Another good thing to do is bookmark that where you found that particular solution, so they can see it too. And maybe it's something that you missed in the solution that didn't make sense to you, but may make sense to them. So that's why I say it's so important to understand what you're reading, understand what you're learning, so that you're able to find the solution. The only way you're going to solve these problems is by doing, by practicing. Okay, so we made it to the end of this particular chapter. I want you to continue to review and go over different things that we've talked about, and just keep on practicing, because remember, the more you do, the more you improve. Okay, see you in the next chapter.